Hi, everybody. So here's the brief lecture on anti-lim, also known as the principle of explosion, because from a single tiny little contradiction, you can suddenly prove, millions of sentences, thousands, trillions, as many as you like. So it's like explodes in its consequences. Another name for it is ex falso quod libet. From a contradiction, anything follows in Latin. Okay. Um, Is it going to work? Okay, so we've already said what this sentence "unti" is, but as a quick recap, it is a sentence of FOL. Doesn't really look like a sentence, but that's what it is. And you can think of it as a short way of writing Q and not Q. In other words, any contradiction. Q is some arbitrary sentence. Doesn't really matter what Q is, right? It sort of has the same effect. And as we've seen, unti is logically impossible and also TT impossible. In other words, it's false in every possible world. And also, wherever it appears on a truth table, it has to be assigned the value F. If you think about it, whatever you assign to Q, Qn, not Q, will also always have the value F. So the same happens with unti. Okay. Unti is visible through the goggles. All right. So anti-lim, we've already met as well. It's normally shown here on the left. So um, after introducing or proving unti, or even, I guess, assuming unti, I don't know if I've ever assumed unti, but I suppose if you did, you could write any sentence you like underneath. But note, you have to stay inside the subproof. You can't bring P outside. That's very important, as we'll see later on. Okay, so there's some criticisms of anti-lim. Maybe and the sentence doesn't really have a proper meaning. Okay. Um, Also, there's something funny about this rule of inference, is it doesn't really seem to provide rational guidance. It seems kind of irrational or silly to believe anti in the first place, but if you're going to believe anti, then you shouldn't then just sort of start believing any random sentence you like. You should stop believing anti, I would say. Um, yeah, and so if we do prove anti in a subproof, then that subproof represents, remember, subproofs represent sort of a state of belief or a belief set that you have at a given time in the proof. That's an irrational um, state of belief. You'd have to be crazy ever to be in that state of belief. So in a sense, it's impossible. It's not possible for a rational being to be in that subproof. So sometimes this state of belief where you believe a contradiction is called epistemic hell. That is, it's hell with respect to belief. So all you got to do is just get the heck out of there, right? And with any subproof, you're always allowed to just stop and go outside at any time. There's careful rules about bringing things with you. Um, like oralim allows you to bring out something you proved twice, or negation lim allows you to, sorry, negation intro allows you to bring out the negation of your assumption. But if you're not bringing any luggage with you, as it were, you're allowed to leave whenever you like. Okay, so maybe the rational advice would be whenever you get a subproof, just go right away. Anyway, why would that not be the best thing to do? Because anti-lim says instead of just leaving, you just go on and believe anything you want. Does that make sense? Okay. Well, does anti have a meaning? Well, it depends what you mean by meaning, if that doesn't sound ridiculously convoluted. Um, if by meaning we mean the content of a possible rational belief, that is some proposition that a rational thinker could believe, then yeah, it has no meaning. Um, can a rational person believe a contradiction? No. Um, in that case, anti has no meaning. Um, and I suppose if we're allowed to have contradictory meanings, then why can't we have, for example, contradictory properties in mathematics? Um, are there square circles in mathematics? Do mathematicians prove theorems about them? I mean, if they did prove theorems, they could prove that every square circle has four sides, but also 10 sides, and also whatever that is, 272 million, etc. sides. And that would just be silly, not sensible mathematics. So why do we do that in logic? Um, well, the kind of meaning that we generally talk about in symbolic logic is that meaning is not content of a rational belief, but meaning is truth conditions. And this is a kind of a coarser notion of meaning. Two different rational beliefs might actually have the same truth conditions, as we've seen with some examples about the morning star and the evening star and so on. So on this account, meaning is truth conditions, then anti does have a meaning, namely the empty set. It is a set of possible worlds, the set where there aren't any possible worlds, the null set. And then according to the standard definition of consequence, where P is a consequence of Q, just in case there's no possible world where Q is true and P is false, something like that. Every sentence P is a logical consequence of anti, because there aren't any possible worlds where anti is true. If there are no worlds where anti is true, then there are no worlds where anti is true and P is false. So technically, every sentence is a logical consequence of anti. And because of the fact on the truth table, anti can't be assigned a truth value T, it's always false. Every sentence is automatically a TT consequence of anti as well. All right. There's no row of the truth table where anti is true and MP is false. Okay. So technically we're on solid ground here, but we still maybe don't feel like this is above board. I mean, what is the point of logic anyway? Well, the point of logic, perhaps, is that it's supposed to give us rational guidance, we might say. You can sometimes think of logic as a path that we're supposed to walk on. As long as we remain logical, we sort of remain on the path of logic. If we do crazy things like believe things that don't follow, then we stray off this path to our peril. So you might picture it kind of like this image here, where there's sort of this narrow path of logic or rationality. You want to stick to the path, because if you stray, you're off the edge, right, and falling to death. It's important to be logical. False beliefs are going to cost you. All right, now, if this is how we think of logic, as sticking to a certain path, then the laws of logic, including the rules of inference, are signposts to help us stay on the path. But anti-elim seems to be the exception. I mean, it tells us to do kind of this crazy thing of believing any random sentence you like after believing a contradiction. How is that helpful? Okay, so this is a challenge we'll have to meet. We'll have to address this problem. Another way of thinking about it is that if we do somehow end up in epistemic hell, briefly, and it's pictured here, notice that in epistemic hell there's contradictions, antis, and there's logically impossible sentences like 1 is equal to 0 or A is not equal to A. Okay, it's a very unpleasant place to be. Fortunately, you can get out of epistemic hell whenever you like, just end the subproof and go out, right? So that's what you should be doing, right? After introducing anti, you should leave right away. But anti-elim says don't do that. Just chill for a little while, believe one or two extra things before leaving. Well, okay, so here's the response to those two objections. So the signpost picture is really misleading. Remember this one? Because if we're believing anti in a subproof, we've already left the path. Okay, rationality doesn't really permit us to believe contradictions. So it's more like once you've left the path of rationality and you're falling, you may as well believe a couple of random things before you hit the ground. How are you making things any worse? Right, it's a bit like that. Okay. Yeah, once you believe anti, you're already off the path, so things can't get any worse. We're already in epistemic hell. But what about the other objection? That if you are in epistemic hell, you should leave right away, not believe random things that don't have any connection with any of your previous premises. Well, yeah, the argument here is that you can't make things worse. Okay. Sometimes I imagine working in some sort of poison helpline where people who've just accidentally swallowed something they shouldn't, they call and say, I just drank some weed killer. What should I do? Um, and when I think about working there, I imagine that sometimes, just once in a while, you might get a call where there's no hope, right? They just say, I just ate 20 grams of plutonium. What should I do? And you want to tell them, well, go hug a tiger, play a few rounds of Russian roulette, then go skydiving without a parachute. I mean, obviously, these are silly things to do that under normal circumstances, will kill you. But since you're dying anyway of plutonium poisoning, you're not making things any worse. So maybe this doesn't sound like a very good justification run to your limb, but at least you're not making things any worse by believing P after you believe on T. Things are already as bad as they can get. Yeah, so you have to leave the subproof. Nobody's advocating staying in a subproof forever once you get on T. That never helps in your proof. But anti-lim says you believe on T, usually just one more thing, and then you get out. Okay. All right, now that might seem all rather silly. So let's think of some more practical reasons why anti-lim is okay. Well, one is that it's unavoidable. Okay, even if you want to get rid of it, you can't. Interesting. It's occasionally useful. There are some proofs where you have to use anti-lim if you want to derive the conclusion, at least in the system we have. And it's also harmless, or you might be wondering about that mostly. We'll talk about that later. There are some theorems you can prove using anti-lim that you might not like, although they are technically TT necessary, so they're correct. Anyway, let's look at these. How is anti-lim unavoidable? So I've got a little proof set up here that is basically anti-lim. You've got a contradiction in your first two premises, or your only two premises, and then some random sentence Q that's unrelated. So I can prove Q just using or intro and DS. Now you're going to say we don't have DS in our system as a rule of inference. Well, that's true, but still we want it to be valid, right? So somehow we want it to be provable in our system. So let's use it here just to show that if you have DS as valid, automatically get anti-lim. So it's pretty simple. From line 1, we can get P or Q by or intro. And then what? Well, then you got it, right? Q follows by DS from 2 and 3. Just like that. Yeah, so there's really no keeping anti-lim at bay without really butchering your system in a way that allows it to, or doesn't allow us to prove things that follow. So I'm just going to have to swallow the pill here, I think. Why is it useful? Well, one of the main things, this isn't the only thing, but one of the main things we can do with anti-lim is actually prove DS so that it is valid in our system, even though it's not one of our rules of inference. Well, not right now anyway, it will be later. And I showed this in class, but let's just repeat it. So we're going to use our lim on line 1, which means we need to have two subproofs, assume P, and oops, I'm going to mess this up somewhere. Okay. Talk amongst yourselves. Okay, assume P and then assume Q. Of course, the Q is what we're pulling out, so we're going to have to derive that, both subproofs. Okay, so let's see. The second subproof is the easy one, so let's do that first. We get Q by Riet from Q at line 6. It's kind of trivial. And then assuming we do get Q twice, we're going to do or lim on line 1 from 3 to 3 to 5 and 6 to 7. All right, now, but somehow this first subproof, we've got to go from P to Q. How the heck are we going to do that? Well, the only way to do it, unfortunately, you might think, is to use anti-intro 2 and 3, and then, oh, there it is, anti-lim. Once we get a contradiction, you might just want to end the subproof and get out, but then you're not going to be able to do that, or lim at line 8. Both subproofs have to end in the thing you want to pull out, which is Q. So you got to prove Q twice. And this, the only way you're going to get Q in that first subproof is from anti-lim. Anti-lim from line 4. And there it is. Okay. So anti-lim is occasionally useful, or you might even say essential, okay, unless you've got other rules to take up the slack. All right. And it's mostly harmless. Now, some students do use anti-lim to prove things that don't follow, but they're not using it correctly. So let's look at this one. Given tet A, we're going to prove cube C. Clearly, this is not valid. This is not TT con, not logical con, not nothing. Let's say not logical con. It's a broader statement, stronger statement. Well, how would you even attempt to prove this using anti-lim? Well, this is what students like to do. They like to assume something they don't know is false. Like in this case, you could assume that A is not a tet, knowing that it is. Of course, you immediately get a contradiction. Anti-intro from 1 and 2, and then cube C from anti-lim on 3. So why is that not the correct use of anti-lim? Well, remember with anti-lim, you do have to stay inside the subproof. Flip back all those slides, but the P underneath anti has to be in the same subproof. You can't take it outside. Here's another analogy. So anti-lim is a bit like one of those open bars you get at some weddings and other parties. Go up to the bar and they say, what would you like? It's all free, and have whatever you want. But there is a restriction. You have to drink it at the party. You can't take it outside. Otherwise, who knows? You could like get 100 free drinks in a big tray, carry them outside, and sell them on the sidewalk to passers-by. Okay, so that's not allowed. All right, you can have what you want, but you have to consume it on the premises. You have to, write down your cube C here, anti-lim from 3. That's okay. You have to consume it on the premises. Whereas you do that, no, that's not allowed. You took it outside, okay? So as long as you stay in the subproof, anti-lim is harmless. It is really harmless. I say mostly just because there's funny things that you can prove later that are true, but look weird. Okay, that's it. Hopefully that makes anti-lim seem a bit more palatable. Help the bitter pill to go down, and hopefully you'll feel comfortable using it. All right.